Hello, this is Jim McKeeth with Embarcadero Technologies, and welcome to this CodeRage 9 session on exploring the brain-computer interface. Real quick about me, I do want to point out I'm not a neuroscientist. I've just done a lot of research into this topic because I think I find it very interesting, and so I encourage you to, not take this as medical advice, if you will, but go out and do some more research on your own. I do provide links where I can. So for the agenda, we're going to start out with the science of reading the brain, and then we're going to look at actually being able to provide direct inputs to the brain, bypassing our normal sensory input channels. We're also going to look at some consumer brain input devices, specifically the Emotiv EPOC, and then we'll do a demonstration where I pre-recorded with a volunteer flying a quadcopter using the Emotiv EPOC and also wearing Google Glass as a biofeedback device. And then finally, I'm going to give you a summary and give you a link to MindTunes, which is this music video that was made using a brain-computer interface. Gartner puts together this thing they call the hype cycle, where they take emerging technologies and they plot them over time against expectations. And they get this nice little curve. And they divide this curve up into these different sections. So it starts out with the innovation trigger, where things are just coming into the awareness, if you will. The innovation is. And then you slowly work their way up expectation-wise over time to the peak of inflated expectations. This is where you're seeing things on the news and hearing about it everywhere, and we think it's going to change the world. But then what happens is we find out that all those expectations aren't going to pan out, and we go through this trough of disillusionment. And then slowly over time, we go through the slope of enlightenment until we reach the plateau of productivity, where things actually are doing what we expect them to do and having the impact we expect them to have. Now, the reason I put this in here is because the technology of the brain-computer interface is actually on the chart here. It's there over there on the left, just on the middle of the innovation trigger upward slope. So according to Gartner, if you look at the little orange triangle down at the bottom, they expect it'll be 10 years or more than 10 years, before the brain-computer interface will be on the plateau of productivity. So it's got to work its way up through the peak of inflated expectations and then down through disillusionment before it can make its way into productivity. You notice up at the top of the peak of inflated expectations is the Internet of Things. So that's why you're seeing that around a lot, or Cisco calls it the Internet of Everything, is the idea that everything is connectable, programmable, and working together. And of course, Embarcadero is a big part of that in being able to help you connect to things through XE7. So the brain-computer interface is really a mainstay of science fiction. This is from the episode of Star Trek Next Generation when Barclay became an interesting character. He was possessed by an alien intelligence and could not interface with the computer fast enough. So he built this brain-computer interface on the holodeck so that his brain could directly interface into the computer and he could achieve faster input to the computer. Now, science fiction's great. I heard this great quote saying that in 5 years' time, the future will look like the science fiction of today. And so if you look at the date on this is 1991, well, a little more than 5 years past that time period here, but you're going to see a lot of the stuff that we've previously seen in science fiction is now science fact today, as we look at the science of reading the brain. So a couple things we're going to talk about. There's two different ways information is extracted from the brain. The first one is neural oscillation, and this is where different brainwave patterns are read. And see, we have the idea of different gamma, beta, theta, delta, etc. So some waves are more conducive or show up when you're in meditative states, other waves show up in the creative states, etc. And so by looking at these different waves and where they're at in the brain, you're able to get a better idea of what's going on in the brain. The other thing that we look at in the brain is hemodynamics, which is blood flow. Where is the blood at in the brain? And so by knowing what parts of the brain are working on certain parts, what have certain responsibilities, by telling where the blood is at, we can tell if it's what's going on in your brain. So this example here talks about looking at where the blood's at in your brain to see if it's a lie or truth. And so an example I can explain for this is that if you're accessing the memory portions of your brain when you're asked a question, then you're more likely telling the truth because you're going back and remembering something that happened. But if instead you're accessing the creative portions of your brain, then that could indicate that you are lying. And that, of course, brings us to our first idea of brain-computer interfaces, which is the polygraph. The polygraph is the idea that different measurements are taken of different systems all over your body, poly being many, graph being messages, and these different systems produce an idea of what's going on in your brain. So it looks at blood pressure, pulse, respiration, skin conductivity, pupil dilation, respiration, etc. And all of these things are indicators of our internal mental state. And so this is the concept that we've all been familiar with over the years, that our brain has external manifestations that are outside of our control. So by looking for changes in these different states, they're able to determine if you're lying or not. Now, the reality is the polygraph really tells if you are stressed or not stressed. And so that indication of stress could be an indication of lying, but not always the case. So polygraphs do require specialized training to be effective, and this is always considered challenging whether it's effective or not. MRI is a system that's used quite a bit actually in clinical systems to look into the brain. And so the way it works is these big magnets in this tube create resonating magnetic waves that resonate with different parts of your brain or any part of your body really, and then it's able to create an image of what's going on in your brain. So this gives you a hemodynamics image of blood flow. They can combine this with a computer software to create what's called a functional MRI, and that's where they're able to do some real-time analysis of what's going on in your brain. I've actually had an MRI before, so you have to make sure there's no metal on you, no conductive metal in the room because of this huge, incredibly powerful electromagnet. And they ask you, they say, hey, are you claustrophobia, where you're afraid of internal enclosed spaces? I'm like, no, I'm fine. And they stick me in this tube, and they say, okay, hold still. And you're in this really tiny tube, and this thing starts making a lot of noise. And all of a sudden, I'm like, you know what? I've changed my mind. I'm claustrophobic now. And they're like, okay, you just have to hold still for an hour while this machine just makes all this crazy noise. So not a fun experience, really, in my opinion, but a very, very powerful way to get images of your brain or anywhere in your body. Another way, very common method, is the EEG, electroencephalography. Electro means electricity. Encephalo actually means brain, and ography means message. And so it uses electricity to get a message from our brain. And so this actually was originally theorized in 1875, and then the first time it was successfully done is 1924. And the way that works is the neurons in your brain produce slight ionic current fluctuations, changes in voltage, that part of which propagate to your scalp. And so by placing all these little electrodes on your scalp, these electrodes pick up the changes, the fluctuations in voltage that result from brain processing. Okay, so the typical scenario that, like this guy you see here, would have gone through is they would have taken like sandpaper or something and rubbed it on the skin to get rid of any dead skin to improve conductivity. And then they put these electrodes with this electroconductive paste. It's kind of a clear gel underneath it that creates a maximum conductivity to get the maximum signal from the brain. So you're looking at usually a half an hour maybe just to get wired up, like you see here. And then they have you wear this thing for a while, doing different tests or just observing your brain, and it creates these brainwave outputs. The little needles go back and forth, or on a computer, the brainwave outputs like I showed you earlier. Very involved process, but is still used today as one of the best ways to see what's going on inside the brain. Now, another way that they do this is magnetoencephalography. Now, if you think back to your high school physics, you'll remember that when there's electrical current, there's also a magnetic field. And so this picks up the fluctuations in magnetic field that result from the electrical current we talked about with electroencephalography. And the main reason I put this slide in here is because the technology it uses to pick up these fluctuations in magnetic fields is called superconducting quantum interference devices, or SQUIDs. Now, if you've seen the movie Strange Day, they also use a device called SQUIDs in there to both read and write from your brain. But it's just such a cool sounding technology. I had to include it in here just to talk about the superconducting quantum interference devices, or SQUIDs, which are used to read the fluctuations in magnetic fields in your brain. And you see they're much larger setup than the EEG. They actually are similar in the way they're able to read the brain, but they're not completely, one's not better than the other, and they don't completely overlap. So there are some differences sometimes where one situation will be better than the other. All right, enough for reading the brain. What about the science of writing to the brain? Now, of course, when we're talking about writing to the brain, of course, you think about the matrix, right? You can plug in, jack into the matrix with your head jack, and in a matter of seconds, you know Kung Fu, or you see the entire matrix construct instead of the real world around you. So there is a technology called transcranial direct-current stimulation. And this is actually in a larger family of just transcranial current stimulation, where they use alternating current or random noise or direct current, which is the idea is basically the opposite of an EEG, where they run electrical current through your brain. So this has been used for a while to treat depression, epilepsy, and things, different brain abnormalities, as well as like phobias and stuff like that. Now, just recently, like in the last year, this has become a do-it-yourself brain hacking craze, if you will. There's actually a subreddit. If you go to reddit.com/r/tDCS, you can find all these people posting comments about how they've built their own tDCS devices at home to run electrical current through your brain. Just recently, DARPA, which is like the American Advanced Defense Research Projects, put out a study where they used tDCS to train snipers. And they did a thing where they had some snipers wearing what's called a sham, where it wasn't actually creating the currents, but they thought they were, and others that were actually receiving the tDCS. And they compared it, and the ones that were getting tDCS did 50% better on the test than the ones that were not. So it was a significant improvement that they received. And so that diagram there is actually showing what's called the montage that they used for the accelerated learning that the snipers went through. So you can actually build your own device for around $20, if not less, if you feel really comfortable with electronics, or you can buy a device for $20 to a few $100s that you can use at home and go out to tDCS placements or that Reddit subreddit and read about how to do this yourself. Now, this is something that is, like I said, just picking up. We're going to see more and more about it. They've been using it clinically for quite a while. They believe what happens is that the electrical current through your brain actually alters your brain chemistry temporarily. So, interesting technology. We're going to see it more and more in the future. We may actually see where athletes are using this in order to give themselves an edge during the training process. And we may see Olympic scandals where they're trying to come out with rules about whether or not this is a legitimate form of training or not. So just like we have magnetoencephalography, we also have TMS, which is transcranial magnetic stimulation. So this is instead using a magnetic field, and this magnetic field in the magnet held outside the brains, outside of the skull, induces a magnetic field or electrical current in the brain as a result of the magnetic field. This is used to treat neurological conditions as well. One of the things this produces is it's flashes of light. I can't remember what they call the term is for it, but just where you're able to perceive these flashes of light as a result of this magnet near your brain. So interesting stuff. They actually have done some interesting work with that, which I'll talk about a little bit. So the third way that they're looking at being able to non-invasively influence the brain is ultrasonic transcranial stimulation. So Sony actually filed a patent back in 2000, and it's supposed to achieve finer targeting to transcranial magnetic stimulation and theoretically invoke sensory experiences. Now, Sony's all about entertainment, right? They have the big screen TVs, the stereo systems, the PlayStations, etc. So they're trying to think, how can we use ultrasound to beam additional information from your TV, entertainment system, whatever, into your brain in order to enhance your entertainment experience. Now, when asked about this, they said that this is actually speculative work. They haven't actually done any experimentation yet, but they do believe if this worked, they would actually be able to greatly enhance your entertainment experience just by beaming ultrasound from your entertainment device to your brain. Fast forward to 2014, research was done using targeted ultrasound to boost sensory perception. They actually did some experimentation moving around, and they found they were targeting the area side. They're targeting an area in the brain the size of an M&M. They didn't say peanut versus plain M&M. I'm hoping it was a plain M&M, which is a pretty small area. So both TMCS, transcranial magnetic stimulation, and transcranial direct current stimulation actually target a rather large area of your brain. This is a very, very small area of the brain. And this is something they're barely doing. Like I said, this was in 2014. So in the next few years, we're going to see more and more research done with this in order to find different ways that they can use this to stimulate the brain. And so it's conceivable in the near future, we may see entertainment devices that are able to beam emotions or senses or whatever into our brain in order to heighten our experience of experiencing things remotely. All right, let's talk some more about how some of these science, how some of this technology has been used to really make science fiction into reality. Some interesting milestones that have occurred. So this is from the movie Brainstorm. This is Christopher Walken, Brainstorm, I think it was in 1983, where he created this thing called the hat, and the hat was able to take sensory information from one person and send it to another person, where the person was able to experience what they were experiencing. So, of course, total science fiction, this has not happened yet, right? Well, turns out in 2013, so would that be 30 years later, the University of Washington built this device where they did brain-to-brain input. They had one person, the sender, wearing an EEG device, electroencephalography device, and it recorded information from their brain. Now, they're looking at a computer screen, and the computer, when the target lined up with the retinal, the aiming site on the computer, they would think fire, okay? And then that EEG would take that information into the computer, send it across the campus internet to another computer, which was then connected to a brain stimulation device, a TMS, transcranial magnetic stimulation device, and it would send that thought of fire into the receiver's brain, and the receiver, when they got the thought fire, would tap the space bar. Now, the receiver described the experience that it wasn't like it was causing their hand to move or like shocking them or something like that, but that they received the thought that it was time to fire. And actually repeated this more recently here using a similar setup, both an EEG and a TMS, and they came up with the idea of the receiver or the sender would think either move my hand or move my feet. And then the receiver would get that, and the move my hand would be a 1, and move my feet would be a 0. And so it would be binary. And this was actually resulted, the receiver received either a flash of light, when we're talking about TMS can produce a flash of light, or no flash of light, and that would be the 1 or the 0. And they could use that to send binary information back and forth. Very inefficient process, but this was built on the previous experience in order to have the possibility of 2 different inputs, right? 2 different states, whereas this one was just a single state. So they're already building on this, and they're already doing new things. In the near future, we may see more and more abilities for us to be telepathically linked, if you will, over a distance, thanks to brain-computer interfaces. Okay, what about the movie Ender's Game, or previously the book? They had the device called a monitor that allowed them to see what the student saw and hear what the student heard. In 2010, a group took a video, and they had an observer watch this video. And so you see here, they're watching the Inspector Clouseau movie, and then they had a computer analyzing their brain. And the computer then was given access to a number of YouTube videos, none of which were the original video. And the computer could then overlay those videos in order to produce a composite video that was similar. Now, if you look at the video on the bottom in the green box, you'll see that it is similar into the above box. You see we have a human form with a light background, and even have the blue looking V around the neck, something similar to that. So quite a bit similarities, and this was completely reconstructed just by observing the brain. So this shows an example of being able to see what somebody saw. IBM used a feedback loop based on the fusiform face area of the observer's brain, which is used in facial recognition. And what they're able to do is actually achieve facial recognition through observing the person's brain. So by observing the person's brain, they're able to recognize the face that the person may or may not have been looking at. And then also hearing what you hear. In 2012, UC Berkeley and Brian Paisley decoded internal neural processing of auditory information. So this is not in the ear, this was in the brain where the brain was processing the auditory information. They're able to reconstruct the sound in the observer's brain, or from the observer's brain on the computer. And the quality was good enough that they could tell that, yes, they were in fact hearing what the observer was hearing, but not good enough that they actually could use it to pirate music for people that go to concerts yet. But definitely interesting and step in the right direction that they're able to hear what somebody hears just by going through their brain. They've also done some experiments using functional MRI to recognize thoughts within the human brain. So they discovered is that one observer could look at some different objects, like a soccer ball, a car, a cat, and then they could take the pictures of the brain, so what the brain looked at when it was looking at these different objects. And then later they could have another subject could look at these objects, and they could discern which object they're looking at by the similarities between the two brains. And so this is interesting because it showed that functional MRI produced similar images in the brain depending on which object you're looking at. Very cool. Another thing that was interesting is actually able to predict 10 seconds in advance before the subject could express their intentions. Okay, so now let's look at some read-only consumer brain interface devices. These are devices that you can buy off the market and use to create consumer brain-computer interfaces today. So Emotiv has three devices: the EPOC, which is what I'm going to show you, the Insight, and the EPOC Plus. The EPOC Plus just came out in October 2014. It's supposed to ship later this month, so it should be out by the time you see this. Insight comes out next year. Insight and EPOC Plus both add Bluetooth LE support, so mobile support, to the headset. So that's a big improvement over the EPOC, which did not have that option. NeuroSky's MindWave has been around for a while. It's a much simpler device. It only has a couple of electrodes. I think exactly 2 electrodes. One's a base electrode. The other one is the measurement electrode. And it actually was shipped in Uncle Milton's Force Trainer, you may have seen, which is a toy where you use your focus in order to try and move this ball up and down. Very, very simple device, but they do have an SDK. People have done some interesting experimentation with it, so it might be something worth checking out. Much cheaper than the other options here. OpenBCI is a new one that's available for pre-order now. It is based on Arduino technology, so it still uses the silicon or the conductive gel electrodes. You can have a lot more electrodes with this by chaining multiple devices together. It's a little more expensive, but it's all based on open source and open technologies. The Neuroelectrics Inbino, which is something I just found out recently about, is a device. I'm not sure what the price is on this one, but they do, because they don't have it on the website, which usually means it's more than you want to spend, but it is a device that's available for sale. And Interaxon's Muse is a device that is shipping now. This one's a really interesting, it's just a little headband that you wear across your forehead. It has, I believe, 7 electrodes, and they do have an SDK, but they're focusing on the idea of just looking at your mental state. So how to deal with stress. And so by having this headset read your stress levels and then give you feedback onto how you're dealing with handling stress, then you have training techniques you can go through in order to reduce your stress level. So you can check those out. I'm going to go ahead and talk to you a little bit more about the Emotiv EPOC, which, like I said, is the device that we're going to use. So this one uses 16 wet electrodes, but instead of being electroconductive gel, it just uses saline, because saline is conductive and it's readily available and it's not messy. Saline solution, just like you'd use in your eyes. There's 14 of those electrodes read brain waves, and then 2 of those are reference electrodes. It also has a gyroscope in there, so it can read head movement. Not going to talk about that very much, just the fact that it's there. So there's 3 different suites of how you can process this information, which we'll talk about more in a minute. So they're wireless. It's a wireless device. It's encrypted to communicate with Windows, Linux, or Mac, and that's the $399 desktop version. But there's also the $499 Bluetooth Smart or Bluetooth LE version that's coming out that will work across Android and iOS as well. No longer encrypted, I believe. I'm not sure exactly how that works because they haven't released it yet. The SDK is backwards compatible, so you can use the existing desktop SDK to talk to the new device. Very exciting. Looking forward to getting a hold of one of those. Emotiv.com. So there's 3 suites. The first suite is called the Expressiv Suite, and this detects facial expressions. And the way this works is it actually uses the EEG sensors, which remember electrodes pick up electrical current, to pick up the signals being sent to the muscles, not the brain waves. Okay, so when you move, you blink your eyes or wiggle your nose or whatever, the muscles in your head send these electrical signals through to move that. And so it picks up these electrical signals that pass through the muscles in order to produce that facial expression. So it's able to read your facial expressions through the EEG sensors. There's other devices like the Myo that is you wear on your arm that picks up arm movements, arm gestures, using the same sort of technology. It's very, very fast, less than 10 milliseconds to respond to these events. The Affectiv Suite, this is similar to, like I said, the Muse uses this sort of thing to read your mental state. So it detects your emotions, excitement, engagement, boredom, meditation, and frustration. And so this is a passive detection you can do over long periods of time, and it produces a variable level. So it says, oh, you're, kind of frustrated, but your excitement's up. So this is really interesting if you think about, for example, using it in gaming, because when you're playing a game, you want to maintain a little bit of frustration, right? So that you should be challenging, but not so challenging that you're ready to quit. And so if you have the game able to monitor your frustration and excitement levels and your engagement, then the game could automatically adjust the difficulty in order to remain as engaging as possible. Very interesting possibility for that. Also could be used in media research. For example, have someone watch a movie trailer or a pilot episode of a TV show, and instead of having them fill out a form or something afterwards, you could immediately know how they felt about it at different times with timestamps coming straight from their brain. Very interesting technology. And like I said, it's here today. This is available in the Emotiv, as well as the Muse also has similar technologies. So Cognitiv Suite, this is the feature of the Emotiv that we're going to use to control the quadcopter. This detects conscious thought. So what you do is you go through a training process where you say, I'm going to think about moving left or moving right or going forward. And then it observes the pattern in your brain, the waves in your brain produced from that, whatever you told it you're going to think about. And then later, it can recognize it and say, oh, I recognize this pattern. This is the pattern we learned earlier for rotate right. And so then it can trigger an event that occurs at varying levels to tell you what magnitude of that thought that you just had. So this is what we're going to use to control the quadcopter. It's not quite as fast as the Expressiv Suite, but it's still pretty fast. So if you want to have a fast input, like let's say hands-free keyboard or something like that, then the Expressiv Suite would be a better choice because you just have eye movements and stuff like that to move things around. But if you have a situation maybe that somebody can't even move their eyes, they don't have control of those muscles even, you could use the Cognitiv Suite to give them access to the computer, to read their mind, to give them an input device without even having any physical control over their motions or of their muscles. Okay, so we put this all together. We put together the Emotiv, which I just talked to you about. We're going to use Google Glass as a biofeedback device. So what this Google Glass is going to do is it's going to display to the wearer what thought is being picked up by the Emotiv. What I found is that previously they would be looking at the computer screen trying to see if they're producing the thought they're trying to produce or something different because it's a little challenging, instead of at the quadcopter that they're trying to fly. And so by using Google Glass, they're able to get that feedback right away, which made it much more productive. And then we're going to use the Parrot AR drone. So the Parrot AR drone, I've talked about previously in different videos, is a quadcopter with an API that you can send it information in order to control it. Very easy. It's semi-autonomous in that it will maintain its altitude and attitude. So you tell it take off and it'll go 3 feet off the ground and it'll just sit there. It does a pretty good job of not, flying around. Whereas most remote control helicopters, you kind of have to do a little effort to maintain its position. So Parrot AR drone does that automatically. So we're going to use the Parrot AR drone's API. We're going to send it basically UDP packets. They're in a certain string format to control that via the software. The Google Glass is going to provide the biofeedback. Google Glass, if you don't know, it runs Android. It's basically all the functionality you would see in like an Android tablet. It's got Bluetooth, Wi-Fi, GPS, etc., all in this little tiny wearable screen. So instead of having a big tablet screen, it's a little screen up on by your eye. It's a tablet instead of phone because it doesn't actually have cellular capabilities, but it does connect to your phone via Bluetooth. Very, very interesting, cool device. And the Emotiv EPOC, they have an SDK. Okay, so now demonstration. Like I said, this was something I previously recorded, but I'm just going to show you how this all works here. Actually, first, though, I'm going to show you some of the different parts of the software and how they all work together. This is the part where it listens for the brain signals from the EEG headset, the EPOC, and then transmits it to the quadcopter. So I actually have this application running here, and all I have to do is select the, we'll say lift, and I've already gone through the training process for this. Now if I think lift, which I'm not very good at, but you saw it blink there a couple times, and for me I think of a red balloon, and I can't think about it and talk about it at the same time, so see it's not working now. But if I stop talking and think about it, I can make the lift show up again. There we go. And now it's showing up just to show off. Anyway, so the process is that you go through a training process where you train for these different commands to recognize what that mental image looks like in your brain. Okay, so for me, I think of a red balloon, or I think of Superman, and what it feels like to be on a plane. And those things all together, see there we go, it popped up again, says lift. Then those things all together is what I use to create the mental image in my brain for lift. And so then when I connect this to the quadcopter over here, then it will fly the quadcopter. Now these buttons in the middle here are because occasionally when I'm flying the quadcopter, it starts to drift into the audience. And so I always have to use like left and right to maneuver back around, or if all else fails, just land it really quick. So what I'll do is I'll go ahead and set this up, connect to the quadcopter, and give you a demo of this actually flying the quadcopter. So I've got my wife wearing the headset now and gone through the training routine. So we've trained her for lift and rotate right. There we go. She did lift. job. Lift. Now can you rotate right again? There's a little rotate right. Okay. Oh, nice rotate right. So we're going to connect the quadcopter now. So you'll watch the quadcopter. I'm going to tap this button here, and the quadcopter is going to lift a few feet off the ground. And then she's going to be able to make it go higher. So it's going to lift 3 feet up and hover, and she can make it go higher or rotate to the right. All right, so that's her rotating it to the right. See, she's rotating it still. And now can you make it go higher? There it goes, lift. Good job. Higher still, see how high you can get it. Oh, there it goes. Oops, it's too close to me. So I'm hitting the forward button to get back on the... There we go, she's going up higher. Okay, now rotate it again. That's okay.
Sorry.
Good job.
You wanted high.
That was high. Thank you. So this is showing not this. The signal we're seeing here is not Chris's brain activity. It's just the kind of reception the electrodes are getting here. So let me see if I can wiggle these around a little bit. Oh, no, it's all black. All right, I'm not going to touch it. We'll just hope it's good. So this is my application I wrote here that does the processing of everything. This is going to connect to the headset and then connect to the quadcopter and send the information back and forth. And then I have another app actually that Chris has running on Google Glass here that I'm going to bring up here as well. So actually tap the side and say, okay, Glass, show my thoughts.
Okay, Glass, show my thoughts.
Did the app pop up?
Sure did.
Okay, great. So he's going to, this display right here is what he sees on Google Glass. And so App Method has this really cool technology called app tethering that allows apps on different devices to be tethered in real time to share information. So that's what I'm doing is I'm going to share the information from the main app to Google Glass so that he's able to see what's going on. So that way he doesn't have to look at the screen, he can just look at the drone. So the first thing we're going to do is we're going to train this to get a mental image of your brain, and then we're going to repeat those commands to control it. So the first training we're going to do is neutral. This is just to get a baseline for your brain, okay? So just neutral thoughts, no pressure at this point. Okay, so now we've got a baseline for your brain. So now we're going to train it to rotate right. So rotate right is going to cause the quadcopter to just rotate to the right. So what I found works really good is not to move, but just to think about something that you associate with rotating right. So it's important to include as much of your brain in this as possible, but the most important thing is it's reproducible.
Okay.
Okay? So whatever you can reproduce that you can associate with rotating right is what we're going to do. All right?
Gotcha.
You ready? All right, so we're training for rotate right now. Okay? So now, go ahead and think rotate right, and we'll see if this bar graph shows anything. There we go. See, it's picking up your thoughts to rotate right. That's good. That's really good. So now I'm going to tap this button here and connect to the quadcopter. And the quadcopter is going to pick up about 3 feet off the ground. Quadcopter is going to pick up about 3 feet off the ground and hover, and at that point, Chris is going to be in control and make rotate right. So if it rotate right, everybody can clap and applause and cheer for Chris here. So here we go. Here it's taking off. All right. So now go ahead and think about rotating right, Chris. There we go. That's Chris right there, rotating it right. All right, and so I'm going to I got controls here too, so I can keep it from running out in the audience and hurting somebody. Although it's got plastic rotors, so it's not going to kill anybody. All right, so next, would it train it for lift, going up? Sound good?
Sure.
Okay. So for me, I think of either a red balloon, the image of a red balloon disappearing, or I think it's a bird, it's a plane, it's Superman, or I think about being on an airplane as it lifts off.
Okay.
So whatever works for you, though,
Sure.
is great. All right, so we're training now. There you go. So think lift again and see if that bar shows up for us. Okay, so, oh, there we go. It showed up. Let's do it one more time. So the more things we're trying to distinguish between, it actually gets more difficult. So it's okay we're going to do this one more time here. So we'll hit train. We're thinking lift. Okay, there we go. That's good. Nice strong lift. Now think rotate right again. See if we can do that one. Okay, that's lift. Can you do rotate right?
That was lift?
That was lift.
That was rotate right, sorry.
So it's actually, we're not only training the drone or the software to recognize the brain patterns, but training our brain to think about specific things, because our brain likes to think about lots of stuff. And so let's try rotate right again. Think about that. All right, so let's train it for rotate right. So there was a university that did this with a full clinical EEG, which had like 4 times as many electrodes. And they said it took about 40 hours to get to the point they could control a quadcopter. So we're going to do this here in a few minutes, but I think you're going to do pretty good here. So let's think about rotating right again. Okay, there we go. Good strong rotate right. Now think about lift. That's rotate right. So I found, especially like with opposites like left and right, that we think about left and then we think right. Oh, right's the opposite of left. Now all of a sudden we thought about left again. So it's important that what we think about is completely separate.
Sure, okay.
All right, so you want to train, let's train for lift again.
Can I just start with a new thought for lift?
Sure, start with a new thought for lift. All right, so lift, up, up, and away. There we go. That's a good lift. Okay, now think about rotating right. That's lift. Oh, there you go. Rotate right. Okay, let's try it. You ready to try it? Go?
I'm ready for lift, yeah.
Okay. So go ahead and lift it up a little bit and see how high if we can get it high enough. There you go. He's lifting it up. Actually, go ahead and hit the ceiling if you want to. As high as you can get it. Of course, now I put the pressure on you, right? Oh, there we go. Hey, you got to the ceiling. Okay. I'll land it now. All right, now we'll take off again, and then we'll do both, okay?
Okay.
So go ahead and bring it up a little bit. There you go. And now rotate to the right. There you go, rotating to the right. Rotate it some more. I know you're doing all the hard work at this point, but it's not wanting to do it, huh?
You remember the tilt-a-whirl at
The tilt-a-whirl? Yeah.
I'm thinking the tilt-a-whirl is not going for me.
Okay. All right, I'm going to go ahead and land it, and let's try something different. What would you like to try next? I'll let you choose.
Like in terms of like a vision or
Or
like
controlling it. How do you want to? What do you want to control it?
Forward, man.
Forward?
Forward.
All right. So that's going to be, if I remember correctly, that's push. So you're pushing. That's either forward or backward. I can't remember actually. But whatever you want to think about is fine. Okay, so you ready?
I'm ready.
All right. So go ahead and start thinking about forward. All right. Oh, look at that. Good strong signal there on forward. Okay, so we'll take off, and you're going to fly forward and fly out all over the audience. So better lift first so you don't hit anybody.
Gotcha.
All right. So think lift. Oh, that's forward. You got forward down good.
Yeah.
All right, so I'm going to try and fly it back here. Oops. Oh, wrong button. Can you just grab that for me real quick? All right, great. So actually, I'll let you talk on the microphone here for a second about how this went for you, what you thought of this.
So obviously the training was interesting. So for the rotate right, I was thinking about tilt-a-whirl. I don't know if you guys remember that from like the carnival or the circus or whatever. And so I was kind of imagining like spinning around really, really fast right. And then for the lift, I was originally trying to think of like an elevator, but I guess that wasn't a very strong emotion. So I went with the up and away like you suggested. That seemed to be better. And then for forward, I was just imagining riding a bicycle, and that seemed to be pretty good.
Excellent. Great.
Maybe we can open up for questions.
Sure. Yeah, give Chris a big round of applause first, then I'll give out some questions.
All right, very cool stuff, very exciting. If you want to see, I think, a really interesting documentary about how they took 3 quadriplegics or tetraplegics is the term that was used. I saw musicians. These are guys that were previously musicians or previously had interest in music or have interest in music, but don't have control over their arms and legs. And they used the Emotiv EPOC and the SDK that I just showed you to allow them to compose a dance track. So they were able to switch between different tracks, mix things and stuff like that all together to create a dance track. So you can check out the dance track there, YouTube link, or the full documentary. If you just Google Mind Tunes on YouTube, you'll probably find it as well. Very cool. I found this very interesting, very enjoyable. Be sure and check that out. For more information, you can feel free to send me an email. You can get information about the Emotiv EPOC, the Parrot AR drone at those websites there. Also, you can check out my blog. I have some blog posts about this as well. And the full slide deck, which is slightly different than what you saw today, is available there on SlideShare. And all my code for the Delphi Emotiv EPOC input device, as well as the quadcopter controlling, is available on GitHub. So there's a separate repository for the AR drone, but it is linked to from that project there. And with that, we're going to go to some questions and answers. You can get information about the Emotiv EPOC, the Parrot AR drone at those websites there. Also, you can check out my blog. I have some blog posts about this as well. And the full slide deck, which is slightly different than what you saw today, is available there on SlideShare. And all my code for the Delphi Emotiv EPOC input device, as well as the quadcopter controlling, is available on GitHub. So there's a separate repository for the AR drone, but it is linked to from that project there. And with that, we're going to go to some questions and answers. Okay, great. Thanks for joining me for this session. This is a lot of fun for me. I've enjoyed sharing this and covering this topic, so glad everybody has enjoyed it. Been a number of people have commented about it and said it was very interesting. Marcus actually apparently has commented, well, this is his field of expertise apparently, and he commented that you probably do not want to use a $20 tDCS device to run current through your brain. So that's probably good advice. Remember, you only have one brain, you can't replace it. So definitely put some research into this and make some considerations before running current through your brain. But either way, it's interesting to learn about this and interesting to see that this is something people are doing at home. And I think we'll definitely be seeing more of this in the near future as a recreational pastime, if you will. So if you do have any questions about the brain computer interface or about the software or whatever, go ahead and post those questions in the question area in the GoToWebinar software. So Jim asked what was the name of the Star Trek episode with Barclay in it where he builds the brain computer face. That's called The Nth Degree. That's the episode where Barclay became an interesting character, if I remember correctly. Before that, he was not very interesting. So the question, Walter's asking what version of Delphi was this project started in. If I remember correctly, I may have started it in XE5, but it has extended with app tethering, which was introduced in XE6. So the app tethering allows it to, that's what was allowing to show the feedback on Google Glass, which if people have used it both before and after, said that makes a huge difference to get that biofeedback right away. And then XE7, I've taken advantage of some of the new Fire UI features in it as well. So I'm pretty sure it started in XE5, but then has come forward with new versions of Delphi as well. You probably get it working, most of it back working in Delphi 5, XE5 if you wanted to, but of course, we'd recommend that you download the trial and try it in there. It was interesting. The first time I did this presentation, tDCS wasn't any sort of it was totally a clinical process. But then in that time, I was refreshing my slides at one point and discovered, oh, now people are doing this at home. It's a hobby. So very, very interesting that that's happened. All right, so a few more questions will come in here. Other than tinkering entertainment, what are the likely applications of this technology, especially in light of the hype cycle that I showed? What's happening in the real world with regard to this technology? So there's a few devices. I showed you the link. There are a few devices coming out there. This is it's just now entering the consumer space, really. The NeuroSky was really early on. Like I said, just one electrode. It really just tells you, concentration was the only thing it could really give you feedback on. But then the Muse and the Emotiv EPOC have really expanded what is possible with this technology. And so we're just now starting to see it. A big place I've seen a lot of work with it is working with people that are disabled, that don't have the ability to move their arms and legs, like the guys in the music video I mentioned, and also the work in gaming. That seems to be the two big applications. In gaming, frankly, oftentimes does push the envelope for technology. So it's interesting that I think that's one of the reasons that they're targeting that area, is because people tend to adopt things quickly there. But I think also the being used for research purposes, as far as especially market research. So having somebody view a movie trailer or a pilot for a TV show and get some feedback as far as their attention and focus and stuff like that from their brain. And Marcus pointed out, that's not incredibly accurate, but you can use this in combination with surveys and other mechanisms that you can use to collect feedback, and it just adds another input point in your data collection. It would be interesting research project to read sound from a brain powered by a cochlear implant and see if those signals match. That would be interesting, actually, to see if that the implant from the would match up. Because interesting. Yeah, that's an interesting idea. Numentia is a company with open source SDK that models human cognition learning. It might be interesting combining with the brain sensing devices with the software. Okay, that's great, Mark. Thank you. There's the link if anybody else wants to take a look at it. About the drone, I think Parrot only has movement controls. Are there any other drones that also allow you to control its payload, such as camera, video feed, etc.? So the drone allows you to send movement controls, and then also you can read the video, although I haven't had any luck decoding the video yet. It's, video encoding is not my strength necessarily, and so I haven't figured out completely how to read the video. I have not found any other drones that do have an API that I can work with, well, at least not in the affordable price range. That's one thing I asked about Parrot. I think it's like $300, so it's a very affordable drone comparatively, especially considering 5 years ago they were, only used by the military and very expensive. But I do have another demo. When I don't have the drone with me, I can use a little Bluetooth controlled car, and the Bluetooth car, because it's Bluetooth, able to interact with the Bluetooth and control it that way. And I believe Daniel TT actually put the interface for talking to the Bluetooth car together, and then all I did is added app tethering so that I could control it via the main app. So if you notice, the screenshot of the app had a slider that said drone, another slider that said Mini Cooper, and the Mini Cooper would be the Bluetooth car. And it had much more limited left, right, forward, backward, no up and down like you have with the drone.